Hello guys, welcome back to Pawan's Code Hub and this is Pawan. So as part of our day 16 of 100 days DSA challenge, we are going to solve LeetCode 88 merge sorted array problem. So let us first understand the problem description what they have given in this problem. So they have clearly mentioned that they have given and two integer arrays called nums1 and nums2 which are sorted in non-decreasing order. So just remember this word. I will explain about non-decreasing order in the later of this video. They have given two integers called m and n, so which represent the number of elements in nums1 and nums2 respectively. So what they are telling in the problem description, they have given us two integer arrays called nums1 and nums2 and they are telling that those are sorted in the non-decreasing order. And apart from that, they have also given us integers called as m and n. So where m represents the length of the nums1 array and n represents the length of the nums2 array. So what we have to do here in this case, we have to merge the two arrays called nums1 and nums2 into a single array which is sorted in the non-decreasing order. So I think the problem description is clear for you. Whatever the two arrays they have given, so we have to merge those two arrays into a single array. So that single array should be sorted in the form of non-decreasing order. Now let us solve this problem by using both brute force approach as well as optimized approach. So coming to the non-decreasing order, so let us first understand what is meant by the non-decreasing order. So non-decreasing order is nothing but the current element should be greater than or equal to the previous element. Is it clear? Whatever the current element it may be, but that current element should be greater than or equal to the previous element. Now let us solve this problem by using the brute force approach. I will clearly explain how to solve this problem by using the brute force approach, and it's your turn to write the code for this problem in the brute force approach. So I will clearly explain what we have to do in the brute force approach. Solving this problem in the brute force approach is very easy, right? So they will give us two arrays, right? So let us consider this is first array and this is second array. Okay, so what we have to do, so we have to just copy the elements from the nums2, right? So we have to copy the elements from nums2 and just place these elements in the nums1 where there are zeros. Clear? So just copy the elements from nums2 and copy those elements into the nums1 where there are zeros. Clear? So, but you people will get it out. Bro, so if we copy the elements from nums2 into nums1 like this, but the resulting array will not be the sorted array, isn't it? I mean, the cannot be sorted in the non-decreasing order, isn't it? So in this case, we are not going to return array at any cost, but this is not the final array. We have to sort this array externally. So how we have to sort this array? Let us see that. So we have copied all the elements from nums2 into the nums1 and we have kept all these elements in the places of zeros, right? So after placing the elements from nums2 into nums1, the array will look like this, right? So this is not the final array. Yeah, that is clear. So what we have to do here, so simply Java, we have a predefined function called arrays.sort. Okay, so what this function does, it sort the array, so which you have passed in the parentheses. Okay, so whatever the array you have passed here, so that array gets sorted in the form of non-decreasing order. Is it clear? So what I'm doing, so by using this function, I'm just simply sorting this array. Okay, but this is the approach which is not preferred. So why I'm telling this is not preferred means, so for sorting this array externally by using arrays.sort, so it is taking an time complexity of order of n log n. Means it is taking an extra time of order of n log n for solving this problem. Since it is taking an order of n log n for solving this problem, it is not the preferred approach. So how can we solve this problem without using an order of n log n? Yeah, so we are coming to that case. So we can solve this problem without using an order of n log n in the optimized approach. Okay, so what will you do now? Just stop this video and write the code for this problem in the brute force approach. You got a clear idea about the brute force approach, right? So just write the code for this problem in the brute force approach, and if you stuck anywhere, ask a doubt in the comment section, or you can also join the Telegram channel and you can also ask. In the brute force approach, let us solve this problem without using any extra space and extra time complexity. Clear? Yeah. So this is the first array and this is the second array. So we all know that they have clearly mentioned that m is the length of the first array and n is the length of the second array. So here in this case, m is 3, means the length of the elements. Don't consider the zeros. Clear? And here in the second case, the length of the second array is 3. Yeah. So 1, 2, 3. Okay. What we have to do? We have to merge these two arrays without any extra time and space complexities, right? So what I'm doing, I'm taking 3 more extra variables called I, j and k. So in I am storing the value as m-1. Means I represents here. Okay, and apart from I'm also taking j, which is used to represent the elements which are present in the nums2 array. So n minus 1 means, so n is 3, right? 3 minus 1 which is equal to 2. And here in this case m is 3, right? 3 minus 1 which is equal to 2. So at the 2th index we are placing I and j. So here I am placing j. And let us take there is one more variable called k. So what is k? K contains the length of both m and n. So k is equal to m plus n minus 1. So what is m plus n minus 1? M is 3 and n is 3 and minus 1 means 6 minus 1 which is equal to 5. So I am placing 5 in k. So in the previous case what we have done, after placing the elements from nums2 into the nums1, we have sorted the nums1 array, right? So that's what we have done in the previous case. But in the optimized approach, we are not sorting the final array at the last. While we are placing the elements from nums2 into the nums1, then only we are checking whether that element is following the non-decreasing order or not. So at a time we are placing the element into the nums1 as well as we are sorting that array. Here we are reducing this. So in this case we are reducing the time complexity in this manner. So we know that I is equal to 2, right? So 2 means, so the nums1 will contain the index positions like 0, 1, 2, 3, 4 and 5. And also in the similar case nums2 array will also contain the array index like 0, 1 and 2, right? So I is equal to 2, right? So I am placing I at 2th index. Is it clear? And also in the similar case I am placing j at 2th index. So I am placing j at 2th index of nums2 array. Is it clear? So now what I am going to do, so just I am comparing the element which is present at nums of I and as well as I am comparing the element which is present at nums of j. Okay. So if the element which is present at nums of I, if this element is greater than the element which is present at nums2 of j, then I am going to place this element at the kth position. Is it clear? So listen carefully once again. So what I am going to do, I am going to fill the elements in nums1, so from the back side. Is it clear? I mean from the end of the array. So what happens, I am taking the two elements, one is from nums1 and another from nums2. So I am comparing and I am placing at the kth position only the biggest element after comparing nums1 of I and nums2 of j. Okay. So if the element I is greater than the element which is present at jth position, then I am placing the element at ith position in the kth position. Is it clear? Otherwise I am placing the element which is present in the nums2 of j in place of nums1 of k. So here k is equal to 5, right? So I am placing k at 5th index. Is it clear? Now let us try run it. So the element which is present at, so nums1 of I means 3. So whether 3 is greater than 6? No. So 3 is not greater than the 6, right? So what I am going to do? So if the element which is present at nums of I is not greater than the element which is present at nums2 of j, so then simply I am placing the element which is present at nums2 of j, so in place of k. So k is 5th index, right? So just in order to avoid the confusion, I am writing this array once again here. So just I will update it here. Okay. So nums1 of k means, so nums1 of 5. So at place of nums1 of 5, I am placing the element which is present at nums2 of j. So what is the element which is present at nums2 of j? 6, right? So I am placing 6 here. Is it clear? So after placing the element, what we have to do? So this element is already placed, no? So no need to consider this element again. So I am decrementing the j and I am placing j at j minus position. So after placing the element, I am decrementing j. Similarly, we have to decrement the k also. Why? Because we have already placed the element at kth position, right? Isn't it? So after placing the element at kth position, we have to reduce the k also, right? K minus. Clear? Now what we have to do? So I is at the same position only, because so I value is not the bigger value. So we are not taking the I. So we are not considering the I. So don't bother about the I. So don't touch the I value. So now let us again compare the element which is present at I and j. So what is the element which is present at I? 3. So and the element which is present at j is 5. So 3 is greater than 5? No, 3 is not greater than the 5. So what we have to do? So just simply place 5 in place of k. So I am placing 5 at nums of k. So nums of k, so k is at 4th index, right? So I am placing the element which is present at nums of j in place of nums1 of 4. So what is that? So I am placing 5 in place of k. Is it clear? Now after that what we will have to do? So we have to decrement the j. So j minus and also we have to decrement the k. Clear? Yeah. So then what we have to do? Again the same process will get repeated. Now let us consider the element which is present at nums1 of I, which is 3, right? So and nums2 of j is 2. So 3 greater than 2. Yes, this condition is true. So in this case what we have to do? At any case we have to place only the bigger value in the kth position. Clear? So I am placing 3 in place of k. So I am placing 3. Is it clear? So after placing k, 3, so I have to decrement I, right? So I am decrementing I, and also similarly I am decrementing k also. So now let us consider I and j positions. So what is there in the nums1 of I? 2, and nums2 of j, that is again 2. So either 2 greater than 2, 2 is not greater than 2, right? Because 2 is equal to 2, isn't it? So in this case what I am going to do? So I am going to place the element which is present at jth position at k. So our k value is present at second index, right? So I am placing element 2 in the second index. So I am placing 2 here, right? So if you see here, we have, after placing element 2 in the kth position, we have to decrement j, right? So I am decrementing j. So after decrementing 0, it will become less than 0. So whenever the element index is less than 0, we have to stop this process. Is it clear? Because there is no element which is present in the nums2. So if there is no element which is present at a negative index, then we should not have to compare the elements. So there is no need to compare the elements, right? So I am stopping the process if nums2 of j, or I mean j less than 0 or I less than 0. So if any one of these index becomes less than 0, I am stopping this process. Is it clear? So if you check this array, so this is already sorted. Clear? So this is sorted in the form of non-decreasing order. So isn't it? Every current element is greater than or equal to the previous element. So 2 is greater than 1, and 2 here, this 2 is greater than or equal to 2, right? So 3 is greater than 2, 5 is greater than 3, and 6 is greater than 6, isn't it? So this is the array which is already sorted in the form of non-decreasing order. So now I will show you the code of this problem in the LeetCode, and you can check it out. So this is the code for the optimized approach which we have solved so far. So I am running this problem. So if you see here, all the test cases got passed, and I am submitting here. Yeah, so if you see here, we have got 100% accuracy, isn't it? So that's how we can solve this problem by using the both brute force and optimized approach. So that's it for day 16, and see you tomorrow. Thank you.